Hi everyone, Mr. Eric Kwa here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Hi everyone, let's go through this prelim question. It is on organic chem on how we can draw curly arrows for a novel reaction. Okay, so here we have the reaction right at the top of our page. So they say the decomposition of fumarate into ethine and carbon dioxide happens through two steps. The first of which forms the neutral diradical species below as the intermediate. So our assignment here is to use curly arrows to show how this intermediate decomposes to ethine and carbon dioxide. So we know from the equation, right, that we are going to get two molecules of carbon dioxide and one ethine. Okay, so if you look at the structure of this diradical, right, you probably will agree with me that the carbon dioxide would come from the top and the bottom part of this diradical. Okay, so these two parts probably will form your carbon dioxide. Okay, so we're going to draw out the displayed structure. C double bond O, C double bond O, and we're going to repeat it for the bottom. C double bond O, C double bond O. So this is what we're going to get as the product. All right, and then the middle part is where you probably will get your ethine, C triple bond C, formed from the C double bond C. Okay, so from here, right, we can see very clearly in between the highlighted parts that the bonds that are to be broken, the covalent bonds, are actually here and here. Okay, the fact that before this, right, they ask you to explain homolytic fission, right? They're trying to give you a hint that when you cleave this covalent bond, you're going to distribute the electrons equally, okay, through fishhook arrows, okay? So which is what we're going to do. Okay, so I want you to observe your products. Okay, so you have the two carbon dioxide. Which are the bonds that you are still lacking? Okay, you are actually still lacking the pi bond here. Okay, likewise the pi bond here. And then you look at the middle part, the ethine, right? What is the bond that you're lacking? The pi bond here. Okay, so these are the three pi bonds that we have to form from our diradical species. Okay, and also from the electrons from this homolytic fission. Okay, so we're gonna use curly arrow to redistribute the two electrons from this covalent bond. Okay, we're gonna distribute it here towards the pi bond, and this radical electron we're gonna distribute it here as well. So you notice, right, when the two electrons are moved towards the place where you're supposed to have the new bond forming, that's how you're gonna form that new bond. Okay, so this new bond is formed right here. Okay, and the CC single bond is cleaved. All right, we're gonna do the same. We're gonna distribute the remaining electrons here towards the triple bond, and then this guy also moving here towards the triple bond. So there you have it. You form the third bond between carbon and carbon. And last of all, you repeat the procedure. Push it towards here, and this radical electron towards the pi bond. Okay, so now we have effectively formed the three pi bonds from this curly arrow, redistributing them to form new bonds and breaking up the original covalent bond. Okay, so just to be clear, right, this part forms your carbon dioxide, this part forms your ethine, and this part forms your carbon dioxide. Alright, so that is how you can actually redistribute and show through the use of curly arrow how you redistribute the electrons to form new bonds and to cleave the bonds in the reactants so that you form your new product. Hope this helps.